Everybody. We are live for this workshop, the Operating with Covenant workshop with myself and Justin Bowie. We are monitoring the chat and the conference platform. So if you guys can hear us, let us know. Since we are live, we're going to give about 60 seconds or so just to get everybody into the workshop before we get started. All right, I'm seeing some comments. Yeah, it is going to be a 2-hour workshop. All right, people are saying we can hear, so that's great. All right, then we're going to go ahead and get started. So people might continue to jump in, but that's all right. Just go ahead and get started. My name is Ryan Cobb. I'm an operator and red teamer at SpectraOps. I like to specialize in kind of like the software development side of, what makes red teaming possible, and like to build offensive security tool sets. It's resulted in some open source tools like Covenant and Sharpsploit. Obviously, we'll be talking a lot about Covenant today. You can find a lot more information about tools I've written and stuff like that at my blog, or on Twitter. I'm on Twitter, as well as GitHub.
Also, Ryan, could you mute your chat noises? I think they were showing up on people's end. My name's Justin Bowie. I go by the handle of SlyDog. You can find me on Medium, Twitter, and GitHub. I'm also an operator and red teamer at SpectraOps. I like to specialize in like payload and post exploitation development. So like getting initial access, and once we have initial access, like what tooling is necessary. A consultant at SpectraOps. I've written a few things, including Sharp Clipboard, Sharp Crash Event Log. One time I tried to write command and control in the form of SkateRat and SkatePark, which was just a C++ implant with a Python 3 server. And then I would try to do front-end development like Ryan does and Cody from our team, and just failed miserably. So I gave up on that. I've spoken at HushCon Seattle, and I really enjoy skating. That's something that I love to do. So yeah, next slide. So here's a small overview of this workshop. So we're going to be introducing Covenant, kind of going over some use cases. We're going to be demoing it in some lab that we have, and we're going to be walking you through a couple different labs. So some of the labs include installing and setting up Covenant, some basic commands in Covenant, so things like move, copy, cd, like everything that you can usually do in a command and control admin panel. We're going to go over how Covenant does credential management. So like what post-exploitation modules actually save credentials for you within a cred store so you can easily use them for later. We're going to go over like peer-to-peer command and control, lateral movement options. We're also going to be demoing like Rubeus and unconstrained delegation, just because it's a very common thing that we find in the field, and kind of doing it through Covenant has a couple little intricacies that we've discovered. And then we'll be going over like extendability of Covenant. So what can you customize in Covenant? You can create custom tasks, adjust the T2 profiles, adjust the implant templates, things like that. And then lastly, we'll be rounding out with a demo from Ryan of the .NET Core implant. So the purpose of this workshop is we're going to learn like the basics and intermediate usage of Covenant. So we're going to set up Covenant, show you how to use it in red team operations. We're going to explain how Covenant works a little bit under the hood. So kind of some advantages to Covenant, some disadvantages to Covenant, how you can use Covenant in like specific situations, and like little quirks that we've discovered. Like I said, we're going to help you understand how to use Covenant in real red team operations, basically like how we've used Covenant in our operations. And then extending Covenant through like creating those custom tasks and modifying C2 profiles and things like that. So for the lab prerequisites, we want you to have just a Linux VM with Covenant installed. We're going to have you basically get a grunt on a Windows 10 VM calling back to this Linux VM. So we needed network connectivity between these two VMs. If you don't have this set up already, you can try to get it set up during these intro slides. And just wanted to make a note on like what we're going to be able to support today. So things that we can help you with are like, how does this work in Covenant under the hood? Or can we do this in Covenant? Or how do you do something in Covenant? Or maybe if there's some like bug or something that you're running something and you're not getting expected output, we can help you troubleshoot things like that specifically within Covenant. But things we won't be able to help with today, just due to time constraints and things, are like technical support issues, like networking issues, or like why can't my VM talk to my other VM and things like that. Just for the sake of time, we can't assist with those issues. So we're kind of going to be breaking this workshop up into like lab and demo time. So we'll be going through like presentations, and then we're going to break off into like lab time, and we're going to give you, I don't know, maybe a couple of minutes depending on how much time we have to go through the lab. And then we're also going to be demoing the lab live so that you guys can just follow along as well. We don't expect everyone to have like a domain joined lab and stuff set up. So we have a lab set up, which we're going to be demoing some domain joined features and things like that.
All right, just to give everyone a quick introduction to what Covenant is. It's a .NET command and control framework. Really the aims of the project are, one, to highlight the attack surface of .NET. That was really kind of the motivation to create it in the first place. But also just to make offensive .NET tradecraft easier for us red team operators, and to serve as like a collaborative C2 platform for red teamers. So it's multi-user, many people can interact and work together on a project. Some of the key features in Covenant is there's a lot of versatility features. So for instance, the server side is written in .NET Core, which makes it cross-platform. So you can run the server on Windows, Linux, or Mac OS. So if you only have like one Windows VM available to you, you can run the server on Windows and test out with implants on the same system. It's multi-user, so you'll see me and Justin interacting with the same Covenant server at the same time, which makes it easier to collaborate. And I think it has a pretty intuitive web interface, which makes it a little easier to get started using the project. There's also built-in implants for both .NET Framework and .NET Core. The .NET Core is a little bit newer, but the .NET Framework one has been around for a while. There's a large library of built-in tasks. These primarily utilize open source projects like Sharpsploit and Ghostpack. And it's really customizable. So as we'll be showing in the labs, there you can create custom tasks for yourself, create C2 profiles to really change what the network traffic looks like on the wire, and you can create your own implants. It'll do handy things for you like track indicators that you can give to your blue team after the operation, and track credentials that you've captured with something like Mimikatz. And finally, there is a peer-to-peer C2 system, which you'll be able to see in the labs as well. A brief description of the high-level architecture. So we have the Covenant server. Really the way that works is it just stands up a GUI that operators will all interact with over their own web browser. It's going to store stuff in a SQLite database on the back end. It also stands up an API that you can interact with for like extendability purposes. And actually listeners use that API under the hood. And finally, you'll have grunts calling back to your listener, and those can be communicate with each other over a peer-to-peer protocol. So I'm seeing I am monitoring for questions in the chat. I do see one question about SOC support. That's definitely on the to-do list, but currently there's no SOC support. So when would you actually use Covenant? A few scenarios that it might make sense to you. I know there's a lot of C2 frameworks out there nowadays, so you kind of have your pick of the litter. So some reasons you might use Covenant is, one, if you want more control over your post-exploitation tasks. In Covenant, there's no forced process injection, which I know in some frameworks can be the case. So that's kind of helpful from either an invasion perspective if you are up against some EDR product that's closely monitoring that. Secondly, if you want a pure .NET Framework implant that can go all the way down to .NET 3.5, it's not going to ever use PowerShell unless you explicitly request it. I know PowerShell used to be kind of the fan favorite, but now can give visibility problems. If you want to use .NET Core implants, I'm not aware of any other C2 that uses .NET Core implants yet, but that's one unique feature in Covenant. If you want really granular control over the C2 structure, like using profiles, or if you just want to change implants, write your own, or track indicators easily. All right, so hopefully you guys all have your VMs up and ready. I want you to get started in your Covenant server VM. First thing you're going to have to do is install .NET 3.1 if you haven't already done so. And here's some brief description of how to do that. These slides should be available within the conference platform. We uploaded them. I'm not exactly sure how you get to them, but hopefully it's obvious. We'll be checking out the chat, so let us know if you're not able to find them. But these are kind of the first things you'll need to do. After you've installed .NET Core, you're going to want to install Covenant. To do that, you'll just clone it from the GitHub repository. One thing to take note of, please use the --recurse -submodules flag when you clone the project, or else you're going to run into problems and you'll have a bad time. Once you've done that, you can use sudo .NET run to start up Covenant, and you should be able to browse there in a web browser. If you're running on Linux, please make sure to use sudo when you run it, or else it's not going to be able to bind to like low-level ports like port 80 when you're standing up your listener. Once you have Covenant running, your first thing you're probably going to want to do is create a listener. To do that, you're going to click on the listeners sidebar, kind of shown in this picture. And then you're going to want to create a HTTP listener. A few other things to pay attention to when you're doing that. First, you might want to change the name just so you can easily reference it in the future. And you might want to change like the bind port or connect port, depending on what you're doing in your operation. Covenant tries to use sane defaults. So for lab purposes, you might not need to change anything, but just some things to pay attention to. And then once you have your listener created, you're going to want to create a payload. So to do that, you're going to click on launchers on the sidebar, and then you're going to want to choose the binary launcher. Once you've done that, you'll need to select the listener that you just created, the implant template you want to use. Probably in this case, you'll just want to use grunt HTTP. Then you'll have to pick a .NET version. It depends on what sort of VM you're using, but in most cases, you'll just want to switch that to .NET 4.0 or .NET 4.0 if you're using Windows 10. And feel free to adjust any of the other options. Those are kind of just the necessary ones. And you should be able to click generate and then download to get a copy of the grunt binary. And then you can go ahead and execute that on your Windows 10 VM to get your first implant. So we're going to pause here and let you guys kind of get started on that first lab here for a couple minutes. And then we'll demo how this is done as well. Yeah, and if you're not able to find the slides in the Hub platform, Justin did post a link in the comments in the chat section, so you can just download them from there. So a few questions coming in. Is there a certain amount of memory requirements for Covenant? Yeah, it can be a bit of a resource hog. I'd recommend probably like 4 gigs of memory at a minimum. You could probably get away with less, but just to be safe. Connect address is the redirector. Yes, if you have a redirector, you would want to point your connect address back at the redirector. If you don't have a redirector, you're just pointing it back at the listener. If Covenant is running in Docker, what IP should the listener be bound to? So the bind IP should probably just be 0.0.0.0, and the connect address should be the address of your Docker host, not the Docker guest. So that's something to be careful of if you're using Docker. So we don't really plan to cover evasion that much. We really view evasion as an additional step for the operator, kind of outside of the framework. And so for this workshop, we're mostly focused on like stuff within the framework itself. But if we have some time during the demos, we can definitely talk about like some obfuscation options. All right, I see somebody got a grunt. That's great. Okay, hopefully you guys can all see my screen. Someone asked, where's the PowerPoint? If you scroll up a bit in the chat, Justin posted a link to it. Oh, he posted it again. It's on the ball. All right, so I'll go ahead and demo some of the basic setup of Covenant. Again, after you get .NET installed, which you can find the instructions for that either on the Covenant wiki or in the slides. After you do that, you're just going to run sudo .NET run in the project folder. Give it a minute to start up. All right, more people have grunts. It's great. Some people with Defender problems. Yeah, it's not surprising that like Windows Defender is going to catch like your stock default generated payloads. So for lab purposes, it might be easy to just go ahead and disable Defender. Or if you want to get fancy, you can work in some evasion. So once Covenant started, you should be able to just navigate in a browser. And the first thing you're going to need to do is register an initial user. It'll allow open registration for the first user. And once that happens, it's no longer going to allow open registration just for security purposes. And you'll be greeted with the dashboard, which is pretty empty at the moment, but it'll start to fill in as we keep on going. And the first thing you might want to do is add all of the users that you're going to be operating with. In your case, maybe if you're just following along, maybe it's just yourself, so you don't need to worry about this part. But since I'm going to be operating with Justin, we're going to go ahead and create a user for him. And we're going to go ahead and make him an administrator too. The other thing you can do, which I do not recommend, is Covenant has UI themes. So the one you're looking at now is the classic theme that looks pretty good. There's also this heathen mode theme that really don't recommend unless you're not a very good person. But just to show you what it looks like, switch to heathen mode, hit edit theme. And it's going to kind of give you an ugly, dark theme. Not very great. So we're going to go ahead and switch back, but just so you know it's there. Okay, now that we've created the users, we're going to first start a listener. So we're going to click this listener sidebar, click create. Running a little slow. There we go. So I'm going to create a listener. I'm going to call it HTTP. That makes sense. Binder address, we're going to keep the same. All this stuff, we're going to keep the same. We're going to switch to the, oh, did I create it? Nope. All right. I'm going to switch to the default HTTP profile. We'll go over HTTP profiles here later. Go ahead and click create. Apologies, it looks like my VM is a little slow. Hopefully yours is a bit faster. See, I've started a revolution on themes. It's okay. Hopefully that got created. Having a little problem. This is a live demo, so this is the risk of the live demo. Go ahead and give this a little restart. Hopefully you're not having as many problems as I am. Okay, we're gonna give that one more shot. Now it's just gonna work great. I can feel it.
I can try setting the server up on my VM too, see if it's a little better. One sec.
Yeah, go ahead and give that a try. I don't know what's going on.
My server's up now too, if you want to try hitting it.
Just gotta get Firefox started first. Okay. We got lots of listeners over here. So I'm just going to go ahead and
just clear all those.
Stop these ones. Sorry for the demo hiccup. Hopefully that's the only one we run into. Do you want to go ahead and create the listener too, Justin?
Yep, one sec.
So the host launcher feature, if you're already creating the payload, it's going to just host on whatever port. It's going to host on the listener that you're hosting on. So if you created a listener on port 80, it's going to host on port 80. If you created a listener on 443, it'll host on 443.
Sorry, I just restarted my server too. I'm trying to get it working.
Cool. Well, hopefully you guys are having a little bit more luck. Let's try this one more time. All right, we have a listener. That was easy. All right. So after that, we're going to go ahead and create a binary launcher like we talked about before. We're going to pick .NET 4.0 and generate that. And then there's also this host feature, so you can directly host launchers on the listener. So we're going to go ahead and try that out. And then we have kind of a little environment set up to kind of demo the payloads in. So we're going to go ahead and switch over here. And obviously, like in a real environment, you're going to need to do some sort of phishing to get the payload onto the system. But for our purposes, we're just going to go ahead and download it. This and kick off the payload. You can see that implant started calling back. So we'll switch over to our grunts view and we can start to interact with it. Now, that's kind of the first lab. We fell a little bit behind on demo problems, but we'll try to catch up here. Hey, Justin, you might need to unmute.
Oops, sorry about that. Yeah, so now that everyone's gotten a grunt and set up their Covenant server and got a grunt callback, we're going to be diving into some of the different tasks that Covenant has. So Covenant has 60 plus built-in tasks. A lot of them are built primarily on Sharpsploit, which Ryan made, and then a lot of things from like Ghost Pack. So things like Rubeus, Sharp DP API, and things like that. And so here's a screenshot of some of the different tasks that are included. So there's like download, upload, and then you have your typical ones like you can run Mimikatz commands, make token, and things like that. One pretty interesting task that Covenant has is the Sharp Shell task. So Sharp Shell allows us to use any Sharpsploit function or any of the built-in .NET framework libraries to basically create custom commands on the fly. So in this image, we're using Sharp Shell, and then we're using tokens. And then we're using, from that token, we're just returning like, who am I? And so the thing to note with Sharp Shell is that your return has to be a string. So here we're returning the string of our users, our current user essentially. So like the same thing would happen if you just did Sharp Shell and you did something like return like test, it would just print out test here. And so, yeah, Sharp Shell is great because we can use all of the different things within Sharpsploit and anything within the .NET framework libraries to just create custom tasking on the fly. So we're going to be going into the next lab, basically. We want you to interact with your grunt, interact with the file system, and kind of just go through all the different commands that Covenant has. So some of the ones that we want you to try are things like cd, so you can change your working directory, ls to list that current directory, ps will list any running processes, who am I, upload, download, and then if you want to run any PowerShell, you can do that using the PowerShell task. You can run .NET assemblies using the assembly task, and then there's a keylogger and Sharp Shell. If you type help in the grunt kind of terminal, you'll get a list of all of the different Covenant tasks. And then if you write help and then a specific task name, it'll output like a little help thing describing the parameters to the task and what the task is doing. And so let me share. Let me get connected up to the Covenant server real quick. Yeah. And so here we're going to use, we're going to go to the grunt that Ryan set up. You can click the grunt name. And then if we hit interact, we can interact with that remote grunt. So if you do like a help here, we can see some of the different modules that Covenant has. And so we can start with a who am I? And this will return our current user context. So we're on the UNSC domain running as the arbiter user. And so you can also run a process listing with PS. And then you can see all the different running processes with their session ID, who owns the process, architecture, and the full path to the process. We have all of the basic like housekeeping commands like So we have like CD. So here we're going to CD to the C dollar. And then we're just going to do a listing of the C dollar as well. One thing to note is that the ls command, you can also list remote shares, which is something that we're going to be demoing later as a way to like kind of test your admin access. Like, can you access C dollar on a remote share? So here's that listing of C dollar, or the C. We also have an upload functionality. So if you just do upload, you can browse using the file browser. We'll just upload. Just upload this to disk just to show off the upload functionality.
Oh, we need to put the file path.
Yeah. Oops. And so here we've uploaded Sharp Clipboard as test.exe. And then I'll also just download that same file just to show off that. So if you just download and then you give the full path, it should download that. And so here we're getting a little download progressed as we're chunking up that download and sending it over the wire. And then we have the complete download. And then if you just click here, you can actually just download that file from the Covenant server to your client. Some of the other things I want to demo are like PowerShell. So we can do PowerShell import. Did I spell that right? And from here, we can import PowerSport. So here we can import like Power View, and you can use essentially any third-party PowerShell scripts. So here I'll just use the get domain user commandlet from PowerShell, or Power View, sorry. And so here it's going to return all of the domain users within our domain. The other thing I want to demo is the assembly feature. So we're going to be running Sharp Clipboard, and then we're going to have Ryan copy pasting some stuff on the target VM. And we should get some output back. So here we're kicking off Sharp Clipboard, which is like a .NET assembly. So you can run any .NET assemblies using the assembly commandlet. And so here we see Ryan send us a little message that dark mode sucks, and send it over and over. Additionally, while Ryan's on that system, we'll also demo the keylogger task. So you can use the keylogger task and specify the number of seconds you want to run that keylogger. So we'll just run it for 20 seconds. And then this will just stream keystrokes back to the Covenant server for the 20 seconds that we specified. And so here we see Ryan saying, hello, hello, SOCON. And you can see like the shifts, and here you see him deleting it. But so yeah, those are some of the basic features within Covenant, like download, upload, the ability to use a bunch of like third-party .NET tooling or PowerShell tooling really helps with the extendability. And then I'm going to pass this back to Ryan.
All right. So let us know in the chat if there's any other features you'd like us to demo. Seeing some questions. Can you change into interactive mode like you do with Cobalt Strike? Yeah, so you can just do, there's like a delay setting on the grunt. You just do help delay. I'm going to show you how to do that. Can you link multiple Covenant servers for long haul and short haul server? No, there's no feature like that. That would be something cool to implement in the future. All right, let's go ahead and move on to the next section. Let's talk about credentials. So Covenant has a lot of handy built-in like credential management tasks. Obviously, everybody's favorite is Mimikatz. So Mimikatz is built into grunts. It has some handy shortcut tasks, so you can just type like logon passwords, and that'll run. Just do DC sync. You also have the ability to just input any Mimikatz command. Mimikatz has a lot of features besides just logon passwords, so it gives you the ability to just run any arbitrary Mimikatz command. And almost, I think all of the Ghost Pack tools are built in as well. So you can do like Rubeus. So for instance, like a Rubeus dump command to get out Kerberos tickets. And Covenant is going to actually track those credentials for you. It's going to detect them in the output of your commands and store them in this data sidebar. If you click on the data sidebar, you'll be able to see passwords you've collected, hashes you've collected, as well as Kerberos tickets. I know this can come sometimes be handy for instances like Rubeus when it has like some white space in the output. It'll just have it all there for you that you can copy paste. And I think, Justin's going to demo how the credential management works.
Yep, let me share my screen. Can you stop sharing, Ryan? I actually can't share right now.
Yep, sorry. Zoom problems.
Yeah.
There we go.
Perfect. Okay, so actually I'm going to log out here and basically show off the multi-user component of Covenant. So if we go to users here, we have Copper as a user administrator, and then also Slydog also as a user and an administrator. One sec. And so we're going to go to our grunt. So our grunt is running in high integrity. So we're able to use things like Mimikatz logon passwords and Rubeus dump to grab credentials. And so we're going to demonstrate that here. So within our grunt, we use logon passwords. This will basically just run Mimikatz Securelsa logon passwords module, and we'll get any plaintext passwords or hashes. So that's running here. We see that there's some credentials for a Master Chief user, and then the Arbiter user, who our current user, and some other credentials as well. You can also run arbitrary Mimikatz commands with the Mimikatz module. So here we're just going to demo the Mimikatz coffee module, very important module in Mimikatz. First thing to do in the morning. So there, we just ran the Mimikatz copy module. And then like we said earlier, there's a couple built-in modules for some of the different GhostBack utilities, one of them being Rubeus. So here we can use Rubeus triage. This will show all the different Kerberos tickets on the system. So here's Rubeus running. And this shows basically all the different Kerberos tickets on the system. Since we're running this from a high privilege user, we're able to triage all of the different Kerberos tickets, not just for our user. And so we actually see here that there is a Kerberos ticket for the Master Chief user. And so we're able to dump for that user.
We realize in your own lab, you might not have a domain joined environment, so you might not have any Rubeus tickets, but it's definitely useful in real operations. We just wanted to show you kind of how that works.
Yep. I'll just do Rubeus dump. I'll just parse it out. So waiting for this. And so here's that ticket for Master Chief right here. And then within the data field, you can see that Covenant automatically parses out these like base 64 tickets, as well as these NCLM hashes from the logon passwords module. So that's pretty handy. So we're going to grab, is there should there be a curb TGT ticket, Ryan? Or am I using this?
Yeah, I think that's that first one right there.
The SIFs one? Oh, perfect.
Yeah. So it only grabs KRB TGTs.
Oh, I see.
Oh, wait, no, that is, you're right. It's SIFs. I don't know what I'm talking about. Yeah, it should have grabbed it.
I'll go back to this and find it from here. Grunts, boom.
It's in the output.
Zoom out of this too. Okay, it's just this one.
Yeah, it should track it, but we can just copy it that way. That works.
Yep. So we can copy this into Visual Studio. And then we're going to want to remove all of the spaces in here. So we can just replace these spaces like so. And then we're also going to want to remove all of the new lines. So now we have the ticket all on one line. So we can easily use that with Rubeus. So the next thing we're going to be doing is if we want to use this ticket, we actually have to make a sacrificial logon session. So keyboard. Can't type into my console right now. One sec. We can create a sacrificial logon session with make token. I'm just going to show you help make token and just show you the syntax. So the syntax is just make token, username, domain name, and password. we're just trying to create a junk logon session for us to use our Kerberos ticket. So we're just going to have a basically test username, test domain, and test password. And this will just set up this sacrificial logon session. Oops, don't know. And so we've successfully created this logon session. And then next we're going to be using create process with token. What was the path that you dropped the launcher to, Ryan?
Just be C users arbiter grunt HTTP. Yeah.
And so now we're going to be using create process with token. I'll just double check that path. I'll see.
I think that's good.
Okay. Make sure we're kicking off the right process. Is it here? Yep, there it is. Credential HTTP. Cool. So we're going to be using that sacrificial logon session, and we're going to be using create process with token to kick off another grunt within that sacrificial logon session using these like junk credentials. We're basically going to be doing all of our Kerberos operations and Kerberos manipulation within this new grunt. So we're going to create process with token, C users arbiter grunt HTTP.exe. This should give us a second callback. Yep, and so here we got a little notification saying that another grunt has been activated. So grunt D12. So we're going to go back to the grunts. We're going to click our new grunt and interact with it. And so here we're going to use the Rubeus PTT module. And so Rubeus PTT will pass the ticket into memory. And so we're going to pass it this base 64 encoded ticket for this master chief user. We're going to wait for this to come back. Perfect. So it says the ticket has been successfully imported. So we're going to be using Rubeus triage just to confirm that and sanity check for ourselves. So here we're doing Rubeus triage. And we see that our current LUID is this 7E069. And we see that within that LUID, we have this master chief ticket. So we've successfully injected that ticket into our current logon session. So now we're able to use this ticket and kind of operate in the environment as this master chief user. So we can do an ls on pelican.unsc.local. This is just a machine that master chief has admin over. And so we're just verifying our admin access by listing out the $C share. So now you see that we've successfully listed out the $C share. And then I think we are going to call it for this demo, and then we'll move over to peer-to-peer with Ryan.
All right. Hopefully you guys are getting used to the grunts, playing with credentials and whatnot. But let's talk peer-to-peer. So Covenant implements a peer-to-peer protocol. So the first grunts you've gotten are, you can kind of see this initial implant over here on the right side, calling back over HTTP, maybe through some firewall in a real environment, back to your Covenant server. When Covenant implements peer-to-peer, it's actually going to use SMB as the peer-to-peer protocol. So when you spin up your new implants, they're going to actually communicate directly to that first implant. So it's not going to go back straight to the Covenant server, but will actually communicate through that first implant you have. Some benefits of this are like decreased noise going out over the edge firewall, as well as like some like internal like high security subnets might actually block outgoing HTTP. So this just gives you a way to kind of get your foothold in on those sort of restricted subnets and kind of subvert those firewalls. So how does the peer-to-peer protocol work? Well, it turns out you can extend that peer-to-peer mesh as far as you would like to. So say we did something like this. We have just one initial egress implant labeled as implant A in this graph. You can see we have a whole mesh of connected SMB peer-to-peer implants. The state of this graph is maintained by covenant on the server side. So the server knows where all of the implants are located within the target network. And when it wants to send a message, let's say to implant G in this case, say you type in shell, who am I for that grunt. What's going to happen is covenant's going to basically recursively encrypt a message along that path. So it's going to take the message, encrypt it with G's key, take that chunk, encrypt it with B's key, take that chunk, encrypt it with A's key, and then that's going to be decrypted as it goes across the wire. So implant will send that message to A, which can decrypt it because it was encrypted with A's key. Same thing with B, and then G will finally unravel the shell who am I message and be able to execute that and return results for you. Grunts used named pipes to communicate over that SMB protocol. One thing to be aware of is the default pipe name is grunt SVC. I wouldn't be surprised if defensive products will be looking for that. So always be sure to change the pipe name if you're using this in the real world. All right, we're going to give you some time to play with peer-to-peer as well as lateral movement. If in your little home lab you don't have like multiple machines to do lateral movement, that's okay. You can do peer-to-peer on the same system. You'll just generate a SMB binary launcher. You'll adjust the name to pipe. Make sure each SMB grunt uses a unique pipe name, but you won't need to worry about that for the first one. You'll upload and execute the launcher through your existing grunt and connect to that grunt using the connect command. And you can use localhost if this is going to be on the same system. So just connect localhost pipe name and it should connect in. So you can do peer-to-peer on just one system. Once you've done that, you can go ahead and navigate to the graph view on the sidebar, and you'll kind of see a graphical representation of what your peer-to-peer mesh looks like. Checking out the questions, has stability of the SMB grunts improved over the last 6 months? Yes, definitely so. Yeah, I'd seen some issues posted about some people having some instability issues with SMB grunts. We got a really high quality pull request from a user that addressed a lot of those. So I think it should be pretty stable at this point. Why not use a default known good pipe to hide within the noise? Yeah, great idea. You know, people like to use like pipe names that Chrome uses or other products use just a similar pipe name to kind of blend in. Can you run the SMB grunt as an assembly? Yes, you can. So you can just do like assembly and then the grunt SMB should work. Yes, we will demo this as well. Now this is where it starts to get a little more complicated, so we'll definitely demo this for you. Feel free to follow along. Yeah, so seeing some suggestions for pipe names. One thing to be aware of, I would recommend not using exactly the same pipe names that Windows will use under the hood. You might run into some issues with that, but maybe pipe names that look similar to them. All right, so let's switch back over to Covenant. See the grunts that Justin has gotten us here. So what we're going to do, now that we have access to Pelican, we're going to want to move laterally to that system, and we're going to do it over peer-to-peer. So we're going to go to our launchers. We're going to click binary launcher. I'm going to say the HTTP listener, because we're still going to communicate with that listener, but we're going to switch the implant template to grunt SMB. That's kind of the key part here. We'll use .NET 4.0, and we're going to change our pipe name. You see the default here is grunt SVC. Not a great idea to use that. We'll just do something simple, pipe 123. Click generate and go ahead and download that file to disk. So here's our grunt running as Master Chief. We're going to, let's first check out where we are on the file system. Yeah, let's change that to here. Go ahead and upload that SMB launcher. We're going to put it SMB. And we're going to use that file that we just downloaded here. All right, so we got that. Uploaded. Let's just check that it's there. And we're just going to copy it over to the other system once we get that verified. Almost got that backwards. What we're going to do. So I'm seeing a question, where's the SMB launcher? Can't find it in launchers. Yeah, so it's not a launcher, it's an implant template. So I'll show it again in just a second after we do the lateral movement, but essentially you want to choose the binary launcher and you just want to choose grunt SMB from the implant templates list. We're just going to use WMI to go ahead and execute a command on the remote system. Grunts do have some built-in lateral movement commands. It's not as complete as I'd like, but it has a few things like WMI. And we're hoping we're going to see an implant start to call back here in just a second. Oh, actually, I almost forgot. So once you execute a SMB grunt, what it's going to do is bind to a named pipe on the remote system, but it's not going to automatically know how to connect into your peer-to-peer mesh. You're going to have to actually use the connect command to connect it in. So we're going to use connect and the host name. In your case, if you're doing this locally, you might want to put localhost as the host name. For us, we're going to put the remote host name. And sorry, this is the pipe name, which we chose pipe 123. And now, once we execute that, we're hopefully going to see it say that it was able to connect. And it did. And we can actually watch as this new implant starts to stage over the network. So we'll see this go to stage 2 and then finally to activated. And we can see that succeeded. And we have our new grunt. running as Master Chief. So like I said before, once you do that, you might want to check out the graph view. Offers kind of a graphical representation of your peer-to-peer mesh. So you can see our listener here. And our initial implant was this one. You can see that second implant that Justin created for us. And then the SMB grunt that we just connected into the mesh. And you can click on the grunts here to kind of go to a more detailed information about them. But I did say I would show you the SMB generation again. So launchers, again, binary. And then here's where you switch to grunt SMB. All right, I'm looking at the chat now. How's everybody doing? Is this all making sense? Able to keep up or need some more time? Yeah, also demo requests. If there's anything in particular you'd like us to demo, just let us know. While we're waiting for those demo requests to come in, can you hack my? No, we cannot. No. Okay. Yeah, we'll let the demo requests come in while we're waiting on those. Let's have Justin's going to give us a little demo.
Yep, 1 second. Let me share my screen. Okay. So we've just gained access to Pelican here over SMB, and we've done some reconnaissance, and it is actually an unconstrained delegation server. And so this is something we run into in the wild quite often, like getting admin access to an unconstrained delegation server, and then being able to grab any Kerberos tickets that are in memory, or like forcing some sort of authentication and then grabbing those Kerberos tickets. So in this case, we're on an unconstrained delegation server. We're going to, because we moved here using WMI, we have no credentials in memory. This is known as the double hop problem. So I'm going to just make, do make token with some valid credentials. And the reason for this is we're going to need, whoops, didn't copy that appropriately. We're going to need valid credentials to authenticate over the network. So doing a make token with some valid credentials. And then anytime I do like a make token, I like to verify my access. So I like to just list out sysvol on the DC just to see if my domain credentials are correct. And so you see here that we're able to list out the sysvol folder. So we're able, that means our credentials are valid and we can authenticate over the domain successfully. And so we're going to create, we're going to do that same trick. We're going to create a process with token. And Ryan, this was just that C grunt SMB, is that correct?
Yeah, that's right.
Okay, thank you. So we're going to create a new grunt with our valid credentials. So we're going to create process with token. And once this kicks off, we're going to try to link to it. Perfect. So now we have a new grunt on here. Oh, actually, totally forgot. You're not allowed to use the same pipe name. So this is actually going to not work. So I'm just going to upload. I'm going to go to launchers. I'm going to go to binary. And then I'm going to go HTTP. Yeah, let's do an SMB launcher. We're going to use .NET 4.0. And then we're going to just use a new unique pipe name. So just slide dog. Generate that. Download that. Okay. Now we're going to go back to our Pelican system. Check our working directory. Oh, is this one dead? This one's active. Oh, I may have killed this grunt. I'm going to go back. Yeah, it's totally dead.
You can
we're going to go.
just issue another connect command from the original grunt. Should be able to fix it.
Okay. So issuing another connect command. Perfect. So we'll go back to our grunts. Oh, here we see it staging over the network again.
I don't think it'll. Oh, well, okay.
So yeah, let's double check this again. Okay, sorry, we're gonna have to go through that process again of doing that make token. So we're gonna do make token. Copy this into Guac. So yeah, lesson learned, don't use the same pipe name or things will break. So we're gonna ls sysvol one more time, just to verify these creds are good. And then we're just gonna go to cd to c dollar, and we're just gonna upload that SMB grunt that we created earlier. So we're gonna upload that to c grunt smb.exe. Oh, that's totally the path. I'm going to upload it to grunt2. And so we see that successfully uploaded. So now we're going to finally be able to use create process with token on c grunt smb2.exe, which we just uploaded. Just double check that this is running. Nope, let's kick that off one more time. Okay, there we go. So it seems to have been tasked. Let's check that that process is running. Cool. So we see that process is running. So now we can issue our connect to it. We're going to be connecting to localhost, and the pipe name was slydog. Perfect. So we should have a new beacon coming in. Here again, we see it staging. Perfect. So now we're going to interact with this new SMB beacon on the unconstrained server. And here's where we can start doing the exciting stuff. We're going to be using Rubeus, and we're going to be monitoring. Actually, let me upload something. I'm going to be uploading spool sample, or the C++ implementation, which is msrprn.exe. This was written by our coworker, Lee Christensen, and we can use this to force a domain controller to authenticate to us on the unconstrained server. And then since it's an unconstrained server, we can actually pull out the domain controller's computer account's TGT and use this to like DC sync. And so we're going to, spool sample. We're going to upload this to msrprn.exe. And so that uploaded successfully. So now we're going to be using Rubeus monitor. We're going to be monitoring every 5 seconds. And then Rubeus monitor has this handy feature called filter user. And we can actually filter out specifically for the domain controller's computer account. The domain controller in this environment is going to be reach. And here you see that Rubeus has been tasked. So now we're going to use that msrprn.exe to force authentication and then capture that TGT. So we're going to use shell msrprn.exe. And then we're going to be, the first parameter is the DC or computer that you want to be targeting that's running the spooler service. And then the second one is the unconstrained server that we've currently compromised. So this is going to reach out to reach the domain controller and then have that authenticate using the spooler service to Pelican. And then since we have this Rubeus monitor working, we'll be able to pull out that TGT from memory. And so sometimes you kind of have to run this multiple times, but it looks like, oh no, so it's progressed a little bit. Oh, and then here we have a new TGT from a new authentication from reach. So we've successfully pulled this TGT. And so we're gonna have to do that same thing. Just put it into here. Replace all the spaces, and then we're gonna have to replace all the new lines as well. Accepting my regular expression. There we go. So now we have the ticket on one line again. And we're going to be doing something similar to what we demoed earlier. We're going to be using Rubeus to pass the ticket again. And then we're going to pass in this, the domain controller's ticket. So it looks like the ticket was successfully imported, but we'll do a Rubeus triage just to triple check that it was uploaded, imported successfully. And so we should see a Kerberos ticket for the domain controller's computer account now. Doesn't return just yet. One sec, did my session timeout? No. Okay. Something was just up with my guacamole session. But you see here now that we have that Kerberos ticket for the reach. And so now, since we are essentially a domain controller for all intents and purposes, we can actually just do DC sync. So this is just built into Covenant. We can do DC sync. Let's grab the Curb TGT account so we can forge golden tickets and be whoever we want on the network. And then you're going to pass in the domain name and then the domain controller, reach.unsc.local. And so if our access is correct, we'll be able to pull out the NTLM for the Curb TGT account.
Maybe try to send that again. Looks like it's
something. Oh, that one's submitted. Perfect.
Oh. There we go.
Yeah, it tricked me. Perfect. And so now we've used that domain controller's computer accounts ticket to grab the NTLM for Curb TGT. So now we're able to forge golden tickets and be whoever we want to be on the domain. So that pretty much concludes our Rubeus and unconstrained delegation demo. As you can see, there's kind of a lot of moving parts. So we thought that this would be a good one to demo. Additionally, because we've ran into this situation many, many times on engagements and kind of had to repeat this whole process. And then I'm going to stop sharing and pass this back to Ryan.
All right. Yeah, so that was a really cool, real world demo. Oh, I'm sharing the wrong screen. Hold on. There it is. Yeah, that was a really cool, real world example, but you may have not been able to do it in your labs, but that's okay. This one, everyone should be able to do. What we're going to do is we're going to talk about some of Covenant's extendability features. The first one being tasks. We've put a lot of work into being able to create custom tasks on the fly, be able to edit your existing tasks. I think it's really important as an operator to be able to have that kind of flexibility to come up with new capability in the middle of an op. So Covenant gives you the ability to do that. If you just click on the tasks sidebar, you'll get a big table of all the existing tasks, but you'll also be able to create new ones or edit those existing ones. So if you click on a task, you'll see a screen kind of like this. Apologies, looks a little blurry, but hopefully you can kind of make out what's going on here. So this is the assembly task. It'll kind of show you the author of the task, allow you to create aliases for the task. An example might be the list directory task has the ls alias, so you can use it using the alias as well. You can specify the language, probably going to be C# in most cases. What .NET versions your task is compatible with. You can add reference source libraries like Sharpsploit. So a lot of the tasks in Covenant use Sharpsploit. So they'll add it as a reference source library and be able to use any of the APIs exposed in that library. And then you can give options. So for instance, the assembly task takes an assembly, which is, the bytes of whatever assembly it's going to take. And you can give it an assembly name. And then the other thing is you're going to specify the code. So this is where you're going to actually write the capability that you want to create as a task. In this case, this is an example of the copy task. So you can see it's really simple. All it does is use the .NET APIs to copy a file from a source to a destination.
One thing you'll need to pay attention to is these parameters to the execute function need to line up with the options that you specify right above. So you'll have a source option, a destination option, and then those will filter its way into this function. So we're going to do a little, so these are all the fields of a task. Most of them we talked about. There's a few others as well. But we're going to go ahead and move into a lab for this. Hopefully everyone's lab, you all have Covenant, so you can do this one. What we're going to do is create a move command. So there is no move command in Covenant, but maybe you're going to create it right now and contribute it back to the project. So what you're going to do is you're going to go to the task page. You're going to click create. You're going to create a move task. Have it handle like local files or even CPaths. That should be fairly easy, just using .NET APIs again. Bonus points if you're able to actually handle files and directories. That'll be a little more involved. When you do this, make sure you add reference assemblies. So every task that does not include a reference source library is going to need to make sure it includes its own reference assemblies. There are some that are just required for all tasks. That's going to be the mscorelib.dll, system.dll, and system.core.dll. You want to make sure to include both .NET versions of those. So in all, you need to make sure you add 6 reference assemblies. You're also going to add 2 options, source and destination. What you can do is a little bit of a shortcut is use the copy command as a template. So create the move command, copy over all the values from copy, and it should be fairly straightforward to alter that into a move command. We're running a little short on time, so we'll probably just go ahead and move into a demo, but please try to follow along with the demo. Going to share my screen. Okay, hopefully you guys see this. The one other feature around tasks that I did want to show you is the import and export feature. So this allows you to share tasks around with your friends. So say you write a really cool capability, you want to share it with all your friends, you can just export the task as a file and send it, and they'll be able to import it back into the project. So to give you an example, I've actually already created a move command that I'm going to import. It just exports to this like .yaml file, and I'm going to import that. Now that I've done that, I should be able to just, let me give this a refresh. Should be able to just search for move. We can see that task that I just imported. And here's what your task should sort of look like after you create it. So you call it move, give it a description. You can put your name and handle and your Twitter link in here if you want. One thing you might want to add is an alias. So you could, for move, you might add like an MV alias if you're used to the Linux terminal. Give it a language, .NET versions, again, those 6 reference assemblies we talked about. And you'll give it a source and destination. And if you saw the last slide, you'll see that this is actually very similar to copy. The only difference is we changed file.copy to file.move. So this is a fairly simple task, but kind of gives you an idea of like the real power of being able to just add capabilities on the fly. So now that we have created this task, I'll show you how you would actually use it. Let's go back to our original grunt. I believe it was this one. Or no, it may have been this one. Let's find a file that we'd like to move. you see we have the C test.exe file. Let's see if we can move that. Do move. One reason I'm excited about this feature is like you don't have to like generate a new implant after you've created a new capability. Since Covenant's tasking pipeline really allows it to get into the grunt even though it wasn't even around when you generated the implant. We can see that got moved. And just to show you that the alias works too, let's go ahead and move it back. And see that that works. All right, I know that was quick. Hopefully you have time to go ahead and play with that on your own, maybe create your own capabilities. Just wanted to make sure we had time to answer all of your questions as well. I know there was one request to run a SMB grunt using only the .NET assembly command instead of using upload. So let's see if we can do that. I think we can get away with it here. I don't think we've run a .NET, run a SMB grunt on the system yet. So we'll use the assembly command. We'll go ahead and upload that grunt SMB payload. Call this grunt SMB, no parameters. Give that a try. Pretty confident this will work, but I guess we'll find out. Seems like it's not taking. Again, live demos. This kind of stuff always happens, but we'll get it to work. All right, looks like that's going. So now we'll have to connect to that grunt. Hopefully we should start to see that stage in. While we're waiting on that, let me see if there's any other questions. I assume SpectropOps doesn't use Covenant out of the box. What are some customization you guys add before you use it in engagement? I'd say we use primarily out of the box. I mean, we use it all the stuff. I mean, the one thing we're going to do is add some evasion, right? So we really consider evasion to be a step for the operator outside of the framework. So like, we're not going to just take like a grunt http.exe binary and upload it and execute it somewhere. Hopefully we're going to see this stage in as I'm talking. So one thing we're going to do is maybe we'll use, I'd say the launcher I use most often is the shellcode launcher. So I'm going to use generate some shellcode, you know, whip up a fancy payload that's going to do like shellcode execution and work that into some sort of like phishing payload. So that's going to be the main thing that's going to change. And then we'll be more selective about like the techniques and stuff we're using within the grunts instead of just uploading like grunt SMB, stuff like that. Seeing if there's any other questions. Oh yeah, Justin said basically the same thing in chat. What would you say the strengths and weaknesses of Covenant are in comparison to Mythic? So I tried to highlight some of the things like situations where I would use Covenant at the beginning of the slide. So I'd recommend taking another look at that slide. I think with Mythic in particular, like that started off as like a Mac OS specific framework, and Covenant started as like a Windows specific framework, and they've now kind of merged since Covenant has Mac and Mythic has Windows. So there's definitely some comparable features. All right, so let's hopefully, is everyone able to follow along? Everyone having success in the labs?
Cool. All right, let me share my screen. Cool. So the next thing we're going to be talking about, so you can create custom tasks in Covenant, but you can also edit the C2 profile. If you're familiar with Cobalt Strike, this might be similar to like Malleable C2 and things in other C2 frameworks as well. But this is essentially modifying how Covenant looks like over the network. And so here from the Listeners tab, there's a little Profiles tab here, and then there's the custom HTTP profile, the default HTTP profile, and then these bridge profiles. These bridge profiles are comparable to external C2 from Cobalt Strike. It allows you to perform command and control over kind of like third-party or non-standard C2 protocols. So when you edit a profile, you're dropped into this page right here. Some of the things that you can edit are the HTTP URLs, so the get and post callback URLs. You can list out a couple different URLs, and Covenant will actually cycle through these different URLs randomly. One of the really cool features of Covenant is actually this message transform feature. It allows you to use C# to basically manipulate the Covenant data that's being sent back. So the Covenant data that is being sent from the grunt to the C2 server is traditionally like a JSON blob with like some sort of unique identifier for the grunt, and then a encrypted blob within that JSON structure as well. And so using this message transform, you can actually manipulate this data and kind of like chunk it up or change it up and spread it out throughout the message that's going back to the C2 server. So by default, we're basically just taking that JSON and then just converting it to base64 and just sending it over the wire. You need a transform function and an invert function, and these should be kind of opposites of each other, because basically one should be transforming the data, and then the other should be like, in a sense, untransforming the data back to its like normal state. Some of the other things you can change are like HTTP request headers, the response headers, and then you can basically change everything about how the HTTP get and post like over the wire. So you can change the actual request and response for each of those. So here's kind of just how that looks. And here's a small slide just showing like you can change the request header. So you can add like server, you can add like any custom headers you want, like adding cookies, adding like host headers for domain fronting, and things like that. And so here's kind of just, again, all of the different features that you have access to when manipulating the custom profiles. And then we're just going to jump into a quick demo of this behavior. Okay, so now we're back here in our Covenant Web UI. We're going to go to listeners and profiles. So if you go listeners here, profiles here, we'll modify the custom HTTP profile. And so we can change the name here. Oops. So you can change the name of the profile. You can change the description of the profile. And here you can modify the HTTP URLs that Covenant is going to be calling back to. And like I said, you can add multiple of these, and it's just going to cycle through all of these different HTTP URLs for get and post. One interesting thing to note here is this kind of like brackets GUID. This GUID is how the Covenant C2 server identifies which grunt is essentially like identifies the different grunts from each other when they're calling back. So you can either place this GUID within this HTTP URL section. You just have to put it in every single URL that you're calling back to. Alternatively, it's shown in another profile here. Alternatively, that GUID can also be in your HTTP request headers. So you see in this profile, that GUID shows up inside this cookie. And so you kind of have like control over where you want to put that GUID, whether it's in this HTTP URLs or within the headers. Just thought it'd be neat to point that out. And so back to editing our profile. So we're going to remove this and we can change this. Just keep this GUID thing. And then we'll change this URL to not malware. And you see I already typed it out. And then we'll change this one to SOCON. Another thing we can change is we can add like cookies and host headers and stuff here. So for the purpose of this test, I'll just do like cookie. And I'll add this slide.cookie. And then some other things we can change are the HTTP GET response. So what the Covenant server basically responds to us. So here we have this data field. And so we can move that data field where we'd like. We can change this to hello SOCON, SOCON, and SOCON. And we can just throw the data field down here maybe. And so you can change where this data field is for the GET response as well as the post response. And so if you hit edit, we'll see that this changed everything for our profile. And so we can start a new listener using this profile. I don't know why listener creation is deciding to act up today.
Yeah,
oh, perfect.
Oh, there we go.
There we go. So we'll just name this HTTP2, and we'll do a bind port of 8080, just so we don't. Oh, did I do something? For the purpose of time, we're actually just going to skip this listener creation. But essentially, when you create that listener, you can just set the new profile, and then all the connections over the wire are going to be using that new profile. Oh, well, yeah, we'll just skip it. And then I'll pass it back to Ryan to talk about implant templates.
All right. Thanks, Justin. Yeah, we're running a little low on time, so we're not going to have time to do kind of these last labs, but I definitely recommend trying them out on your own and let us know how it goes. We're happy to chat after the workshop about it. I'm going to at least talk about implant extendability, but probably won't have time to demo that. And then I know people are asking for a .NET Core implant demo, so I'll try to fit that in too. So one of the really cool features in Covenant is you can create your own implants or actually edit how an implant works. I think that's like a really powerful feature for operators to be able to like modify implant behavior on the fly. So you can see, you click on the left side, this templates sidebar, you can see kind of the existing templates, and you can go in and edit any of the code. The lab we had in mind for it was to create a new implant that will auto hide the window. So you may have seen like in the very beginning, like it doesn't auto hide the window if you already have a window open. So this is something like some people have preferred to add into their implant. we have all the code available for it there. It's just a couple of API calls that you can add into your implant. So try that out on your own and let us know how it goes. But just in the interest of time, we're going to skip the demo on that. I know people were requesting the .NET Core implant demo, so we're going to try to fit that in real quick here before we run out of time. All right, so to do that, we're going to go back to our binary launcher. And the key here is the implant template. So instead of the grunt HTTP one, we're going to use the brute template. You can see our available .NET Core versions change. It's going to be, the only option is going to be .NET Core 3.1. And we're just going to go ahead and run it on this Linux system we're already on. So I'm going to switch this to Linux 64. Click generate on that. Just as a quick self plug, there is a .NET Core for malware talk that I'll be doing in about, I forget what time, maybe 12:30 Pacific, I want to say is right, but check the con schedule. Once that's generated, you can go ahead and click download. The downside of the brute implant is they can be a little large, so it takes a second to download. So these turn out to be, I think, around 30 megabytes. But once it's downloaded, did we download it? Thought we downloaded it. It does sometimes take a minute for the download to work, but usually not quite this long. Give it one last try. For some reason, the download wasn't working, but I'm going to go ahead and cheat and just execute it out of here. But usually it should just execute. Hopefully we'll see that callback come in. There we go. We got it. There's our brute implant. You can see we can get .NET Core implants with a limited selection of tasks, but it has all the really important ones like shell, upload, download, even assembly execution. You just have to do a .NET Core assembly, not a .NET Framework assembly. All right. So that's a quick demo. Hopefully you have some more time to play with that on your own or check out the .NET Core for malware talk. I think we are running up on time Hopefully we can close this out real quick. If I can find the screen. All right. Question and answers, we'll probably have to take that to the LobbyCon Slack chat. Let us know how the labs went and if you have any more questions there. Other than that. Oh yeah, the chat in the session will continue. So we'll keep answering questions there for a little while. I think Justin will have to head out to his talk, but I'll be available for questions. So thanks everybody for attending. Hopefully learned a few things about Covenant.
Thanks, everyone.
Oh yeah, sorry, I was peeing. Cody, you want to go first? Right.
Yeah.
Oh, this is Cody, not me.
Yeah. Let me stop share.
Yeah, Mike. Are we still live on the thing? We're also saying that we're still streaming.